521 Construction was awarded the 521 Brewery project to build a 200,751 square foot brewery on the northeast section of Valley View Casino Center parking lot. As a hired construction company, we will design a site logistics plan, phasing plan, SWIP, and traffic control plan, along with a detailed engineer's estimate, construction schedule, water and wastewater treatment, and stormwater design.
Oh hey, didn't see you there. Alex Rittenberg, BIM coordinator.
I would now like to take you on a general overview of our site layout. This will be during the main construction and structural phase. As we come in the north gate, you'll notice a security booth to keep out unauthorized personnel. This will help keep the site secure. As we come around, you will notice the construction trailer and office, along with the subcontractor storage area, denoted by the purple. If we come around, you can see the Revit model of the building, and here we have our delivery and laydown area for when material and product is delivered on site. We'll have a mobile crane to move around the building. Here we have trash and recycling bins along with a water truck to keep unwanted dust down on site. Just outside the site, we'll provide employee parking for all the people working on site. They'll enter through the south gate, where we have emergency area, rest area, and temporary toilets. There will be another security booth at the south gate to ensure unwanted visitors do not enter site. Trucks will make a full stop before exiting and carry on down the street.
Hi, I'm Jake Neely. I'll be talking about the site utilization plan.
Now that you have a better understanding of what our job site looks like, I will now walk you through Phase 2, 3, and 4 of our site logistics plan. Phase 2 is considered our earthwork phase, and during this phase we will start by mobilizing on site and setting up our SWIP perimeter fence line. Other activities on this site consist of asphalt that will be stripped from the existing parking lot, underground utilities that will be installed, and footings that will be excavated. For the foundation work is the final portion of Phase 2, which is the formwork, concrete placement, and stripping of forms. During Phase 3 will consist of our erection of the steel structure. This phase will be complete when the building is considered watertight. During this phase, a mobile crane will be on site, and there will be a material laydown area, which you can see in blue, which is parallel to our main access route. Because of the safety risks of having a mobile crane on site and moving around frequently, a safety engineer will be brought on site to supervise all of the hazardous work, and any additional field engineers will be brought on site to manage the quality of inspections and the overall safety of our job site. During Phase 4 of our plan, there will be an influx of laborers. All MEP subs will be racing to get their rough-ins done first. There is a lot of specialty plumbing involved in this project. Specialty brewing equipment and water treatment systems will need to be installed. Again, a safety manager will be needed to supervise all of this hazardous work. The field engineers will also play a big role in this phase, and it is possible to have an additional staff member during Phase 4 to aid in the passing of the fire marshal's inspections and completing all punch list items. Substantial completion will mark the date in which the owner will begin moving in and performing all of its trial brews. All the remaining work, such as the exterior of the building, will be done during this phase.
Oh, didn't see you there. Landon's the name, SWIP's the game.
First thing we're going to go over is the narrative describing how we're going to be implementing the SWIP into our project. So as you can see here, our first thing we're going to be doing is to preserve vegetation. That's going to be kind of handled by just the whole setup of our project. We're going to have a buffer zone around it just to kind of preserve any natural vegetation around the site. Next thing we're going to go over is construction access. The construction access will be through already existing paved ways from the surrounding landscape. So we're just going to make sure we have a clear planned route for everything to go in and out of the site. This will also help limit the sediment that goes on and off site, especially with the use of Roman plates that we'll also have. The next thing we'll be going over is control flow rates. So this is, we're going to control our flow rates by just monitoring them, and along with that, we're going to be using fiber rolls to keep our sediment on site as opposed to flowing off. And then that also flows into the sediment controls, which is how we're minimizing the sediment left on site. So that is, again, the fiber rolls, and we'll have silt fencing if it comes down to that during the rainier season. Along with that, we're also going to be implementing gravel fiber beams. So the next thing we're going to be talking about is erosion control. The erosion control will be utilized to help reduce soil runoff and erosion. And again, with the buffer zone, we'll be implementing that. We'll have mulch, plastic sheeting, and we'll also have a designated parking area off-site to keep from vehicles tracking on sediment, which will eventually lead to erosion. So there's that. And then the next thing we'll go over is how we're going to stabilize our soils. So for this, our soils will remain they will not remain unworked or exposed for more than 2 days at a time. So we'll be having tarping and other such things to not let our soils be exposed for long periods of times. So we're just going to be aware of what's happening. And on top of that, we'll have some dust control measures. We'll have water trucks available if it needs that. The next thing is protecting drain inlets. Just with that, we will be using storm drain inlet protection. This could be found in our SWIP report, which will be talked about a little bit later. And then controlling pollutants. This is just a thing that's more of on a managerial aspect, just being aware of what we're using, what materials, fuel equipment, and waste, and just managing that. And that falls into our last thing, management project, which is really important for a SWIP. We got to make sure we're on top of it. We have a SQP on site at all times, and just everyone's aware of the SWIP on our project. So what we're going to talk about next is type of controls, our control plan, and other important information. So just the types of controls, we'll have sediment and erosion controls, and the control plan is just how we're going to be implementing it. Like, for example, we're going to have covering and wetting of the ground, so we're going to be using water trucks and have periodic wetting of the ground, the site, just to keep the dust down, which was mentioned earlier. And then for another type of control is our concrete waste, so we need to make sure that we are keeping that accounted for. And then important information on that is that it needs to be cleaned out when it's 75% full, so we can't be running over with that. And then just like implementing our fiber and silt rules, those need to be constantly implemented, updated, maintained. So that's another thing that we have to be on top of. And then just making sure we're on top of all of our SWIP implementations, and we have our geotechs reports, which helps with the controls. And that's kind of that for the SWIP controls, just what we're going to be doing and how we implement it. And then finally, and this is our SWIP drawing, so you could take a look at this for a second, just see where we're going to be implementing what we have on site for SWIP controls. Thank you.
Oh, hey there. I'm Valenza Dedo, and I'm project manager. We developed a delivery traffic control plan for our project in order to minimize traffic delays and accidents. The delivery entrance and exits are located on Kirch Street, which is a highly populated industrial area. There is a lot of vehicle traffic to the nearby businesses, and in order to mitigate traffic, we set up flaggers on the entrance and exit of our job site. We tapered off the entrance in order to reduce the oncoming speed of traffic and allow the oversized delivery trucks to make their wide turns onto the job site. The flagger on the exit end is there to warn and stop traffic while the oversized trucks leave onto the designated haul routes. With this plan, we will be able to keep the flow of vehicular and pedestrian traffic safe from the construction traffic, as well as having an efficient route for the construction deliveries.
Hey, I'm Costa Papadopoulos, and I'm going to talk to you about the construction schedule. The construction schedule has been broken down into 4 phases. Typically, projects are broken down into phases in order to complete construction in different sections. Because our site is so small, we will not be dividing the construction into different sections. However, our phases are still significant because they mark the dates where our staffing and overhead costs will change. The third and fourth phases will require a significantly larger on-site staff and higher overhead costs than the first two phases. The critical path of this project begins with earthwork and building the foundation. Next on the critical path is to erect the building skeleton. Once the building is standing, the next critical portion of work is to make the building watertight. After the building envelope has been created, subs can start to install MEPs and complete the building finishes. The project is scheduled to be substantially completed in late April of 2017. This will allow the owner to begin brewing some test batches and to begin business as soon as the project is turned over to them at the final completion date on June 23, 2017.
Oh hey, Smith Kleinschmidt, lead estimator.
For the construction estimate, we were able to develop a detailed breakdown of each building system and then categorize the tasks by CSI division to be able to compile a complete budget for the project. We started by completing takeoffs of the building from the floor plans to use as our quantities. Then we used historical data as well as information from the RS Means Buildings and Construction Manual to find the rest of our unit costs. With this data, we were able to come up with our cost per task. The Excel spreadsheet helped with our organization of the estimate and gave us the ability to separate each CSI division within the tabs to come up with our breakdown by CSI division. These breakdowns are useful to have for the owner meetings as well as for being able to use as quality control check with the subcontractor bids. This project will end up costing about $8.3 million, including general conditions, on-site improvements, structural, exterior envelope, finishes, equipment, and mechanical, electrical, and plumbing.
Hey there, Christina Stewart, Water Resource Specialist.
I am here to talk to you guys today about the water and wastewater treatment project for 521 Construction Brewery. And first of all, the reason why we want to have our water and wastewater treatment is to meet sustainable standards for San Diego. Most breweries do not do wastewater treatment and reuse it, so that is why we are designing the wastewater treatment aspect of this project. So our water is coming from the Alvarado treatment plant, and from the drinking quality report in 2014, the parameters listed in the table are what is going to dictate why we need to treat the water for the brewer standards. So the pre-treatment of the water, of the city's drinking water, will start off with carbon absorption, which is basically like a Brita filter. And then it goes into the microfiltration and then reverse osmosis. These three pre-treatment processes will get the water ready for the brewery process. And then after the brewery process, we go into the wastewater treatment aspect of the project, which starts off with this wastewater treatment process will start with a large sump that will collect all the brewery wastewater, and then this will be passed along to a rotary screen, afterwards leading to a large equalization tank, and then sending it through to an aeration tank. Then after that, a mixed batch reactor, an ultrafiltration tank, and then reverse osmosis. These processes will get the wastewater ready for reuse in process design.
Oh hey, didn't see you there. Clint Gibson, Stormwater Specialist.
Welcome to our stormwater study. So, this is our property. Parking lot area is 6,920 square feet. So that's the area we're going to be focusing on for our rain and our stormwater study. So, according to the design drainage manual, we will be using the rational method. The rational method is where Q equals CIA. C is for runoff coefficient, I for intensity, and A in acres is the area. And of course, Q is the runoff in CFS, or cubic feet per second. So for our runoff coefficient, we have an asphalt driveway and parking lot. And so according to this table that I've included from the design drainage manual, will be drives and walkways, so we'll be using our C of 0.75. For an intensity, we're specified to use an intensity of a 50-year storm event with a 1-hour duration. So if you go over here to the table, 1-hour duration up to 50 years is 1.2 inches per year. So that'll be our I. In our area, so we're just using the outside area. The building is not going to be part of this stormwater study. So that's 6,920 square feet. And so we need that in acres. So since 1 acre is 43,560 square feet, our area in acres is 0.159. So calculations. We take our cubical CAA and add RC, RI, and RA, and we get a runoff of 0.143 cubic feet per second. So therefore, our drains must be able to handle that flow in case of a 50-year storm event. So we will also be collecting our rainwater in order to be more sustainable and save money and the environment in the process. So we're collecting it from our roof, and then we're going to run the rainwater back into our recycled water. So our roof area is 20,751 square feet, and the average San Diego rainfall is 10.34 inches per year, or 0.862 feet per year. So the volume of water that we'll be collecting is, you multiply our roof area by how much rain in feet per year we're going to get, and we get 17,887 cubic feet per year. And if you convert cubic feet to gallons, it equals 133,485 gallons per year, in which we'll be saving per our water usage.